Hello and welcome to Geology 1B, Historical Geology, and today I'm going to talk about the lab on the survey of vertebrates. And we're going to start off with the coordinates in general. So again, you're going to have to read through the lab, and the answers to the questions here will be based on the text that you'll be reading. And remember, the key thing is some of these are going to ask you to label some features on these diagrams, and I do want you to label these. Some labs have been turned in without any labels or any work done on the figures, so make sure you get those figures annotated correctly. The next part, fishes. So again, all this is pretty straightforward background material, and there was one section down here on the weight of a dinosaur, and so that's where I want to get to and introduce the data. Yeah, so it's this activity which deals with this figure 14, and I have a similar setup. I made a couple of videos that I'm going to show here that's going to help you fill out this worksheet here. So the key thing about this worksheet is I'm going to start off with the actual length of a dinosaur, and we're going to be doing Acrocanthosaurus today, and you'll see in the video that I present Acrocanthosaurus. It's related to Allosaurus, so it's related to the Carnosaurus. And so Allosaurus, Acrocanthosaurus, very similar. 12 meters long, so that's 1,200 centimeters. That would go here. And then you'll see that I'm going to measure the dinosaur using the tape, and you'll see in the model that how I do that. And then once you get now you know 1,200, the length of Acrocanthosaurus, I'll give you the measured length I get in the video that's coming up next, and then you're going to have to figure out the calculation here. Then I'm going to show you how to do this volume displacement, where we submerge the model into this beaker, and I do that essentially very similar to this, and so I'm going to bring those videos in next. All right, here we're going to measure these dinosaurs. So we have Acrocanthosaurus right here, we have Parasaurolophus there in the middle, and Stegosaurus, and the lab says we need to use some sort of masking tape. I'm going to use this blue painter's tape to measure the length of these three dinosaurs. Oh, note that there's an interloper in the back there. See, we'll talk about that guy later. But anyways, what I'll do, I'll measure these. I'll do the first one, or 3 centimeters. It's already 3 centimeters, but it says to place it along the length of the dinosaur. So I'll do that here. And then you kind of use a tape to come along here. And it's going to get all scrunched up, it said, in the lab. But we'll go along the whole length here. I guess we're doing the whole tail here. And it goes right about to there. All right, so then we're going to mark it just to kind of save our tape so we can reuse it. And so that'll be the length of Acrocanthosaurus. Okay, so since we're doing Acrocanthosaurus first, it's 12 meters, the fossils, so in life it was, so that equates to 1,200 centimeters. So for the length of Acrocanthosaurus, we'll put 1,200 centimeters. And now we're going to measure the length over here. We already measured the length with a masking tape. And in here we're seeing, this is, what do we got here? 15 centimeters. So 15 to here. And then let's do the rest here. So we got 15 and another 10, that's 25. Well, look, exactly 26 centimeters, 26 centimeters. So let's put that over here. So the length of the model here for Acrocanthosaurus, which is, he's over here, is 26 centimeters. All right, so now your job is to do the math here for number 3, right? We're going to divide the length of the actual dinosaur by the length of the model, right? And they're both in centimeters, right? So you'll divide 1,200 by 26 centimeters to give you that number. And then we need to figure out the volume, all right? So I have the apparatus set up over here where I have this 2,000 milliliter beaker, and I have the graduated cylinder in the back. We're going to figure out the displacement. So the whole idea is using Archimedes' principle of volume displacement. So remember the story about how the king asked Archimedes to figure out whether the crown was really gold or not, and he realized that when he got in the bathtub, there was a water displacement. So that we're going to do that experiment right here. And the way I've set it up here is I have the bead of water. Remember the surface tension of water here.
And it's kind of hanging right over the edge of the lip. You can sort of see it right there. And you got to be careful. You have to have the exact amount. And then hopefully the water will spill out that lip and into this pie tin that I have down here. Then I can collect all the water out of the pie tin and place it into my graduated cylinder to figure out the volume displacement. So let's try that experiment now. Hopefully this Acrocanthosaurus fits all the way into this beaker. And so now the water is pouring out. I'm just gonna let it go all the way in there. Oh, the little tail's sticking out. There we go. Push that tail in a little bit. Okay, so now you can see there's water down at the bottom. So our job next will be to collect that water, put it in the funnel here, and put it in the graduated cylinder. All right, so now I'm gonna shake off as much water off these little rubber stoppers that I had holding up the beaker. Hopefully I can get all that water. All right, and then we're gonna pour this into the graduated cylinder to see what the volume is gonna be here. Oop. Every last drop. Because we're doing science. All right, so when we look at this, we want to measure, well, it looks like there was some soap in this funnel. That's from my dishwasher. But anyways, we got 60, so with the graduations on here, so it's, so each graduation is 1 milliliter. Yeah, so there's 10 milliliters. So we got 65, and it's not quite 70, right? So it's like 65, 6, 7, 8, 9. It's about 69 milliliters. 69 millimeters exactly. So we'll go over here to our lab, and then on the lab sheet, we're going to enter the volume displacement here will be 69 milliliters, right? Okay, so it looks like we have all the information that you need to calculate the rest of the problems here through number 9, then answer the question at the bottom here. And I did the calculations, and amazingly, it came out to what I found. So go ahead and do this, and it seemed to work pretty well. What I'm gonna do next, I'm not gonna make a video of this, but I'm gonna do the volume displacements of both Stegosaurus and Parasaurolophus, and I'll include those as a PDF file or something. And what I'll do, maybe I'll make those extra credit for you guys. How does that sound? All right, check it out for now.